Hi everybody. Today I am going to show you how to solve this problem. It says distributed load of 50 kilonewton per meter may occupy any positions either continuously or in patches on the girder PQRST. So these distributed load, it may occupy any positions in two ways, either continuously or in patches. I mean here or here or here or here in patches way. So there are two ways too. And we need to find the maximum negative Hogging bending moment at these position point R. Also, we need to see out of these four, which one is correct answer. Also here we can see the distance for cantilever part. It is 1.5 meter, 1.5 meter, and these in between these two supports, it is not at the midpoints. It is actually from here 3 meter, from S support it is 2 meter. So we have to consider this distance. So let's move ahead to see how to solve this problem. To solve this problem, we need to apply the Muller Breslau principles, especially for internal moments. An internal moment influence line for a point, say R. It is constructed by breaking the beam for moment at that point. This is a very important point to understand. That is why we can say that it is easier to conceptualize, because adding an internal hinge to the beam at this point, it easily releases the internal moment restraint. So what we'll do to find the influence line for an internal moment at this point R, we are going to add a hinge to the beam. So what will happen? Once we put hinge to the beam at this point, it will rotate the beam at this point by a total of 1 unit, I mean 1 radian. We can see it here. Also, I have shown here, this is the point. By this rotation, it creates an angle alpha 1, here alpha 2. So once we get these two, right here we can also put the angle for this one and this one also. I mean, for this triangle it will be alpha 1, and for this triangle also this will be alpha 2. Now what we will do, so surely we got the idea that this alpha 1 and alpha 2, basically 1 radian, what we rotated here, it is adding these two, it will be 1 unit. Because this total angle, I mean 1 unit, it is split between the two triangles. As we can see, how it is splitted in inverse proportional to the base length of the triangles. Very important point to understand. So once we understand this, so we can find this R prime, these ordinates. So what we will write now? For the left triangle, say QR prime. This slope, what will be the value for this? 1 multiplied by 2 by 5 equal to 0.4. Again, for this triangle, we will get 1, because this is unit, 1 unit alpha 1 alpha 2. We need how much is split for this, how much for this. So this will be 2 by 5. So surely this part will be 3 by 5. Already I said it is split between two triangles in inverse proportional to the base length of the triangles. That's what it is. Now, once we get these two, surely we can find the height of the triangle, I mean this height. Height of the triangle, I mean RR prime. This is RR prime. Here I should put comma. Anyway, RR prime equal to, in two ways we can calculate. If we take from left side 0.4 into 3, we get 1.2. So this RR prime is 1.2. Or if I consider from the right, 0.6 multiplied by 2, it will be also 1.2 RR prime. Why not we write it here 1.2? So we got it. Now our target is to find this height, this ordinate for this triangle, and also this height. So let's see that. Triangle QRR prime and triangle QPP prime, both are similar triangle. So once we find that it is similar triangle, surely we can write ratio means this 1.2 divided by PP prime equal to this 3 meter divided by 1.5 meter. So from that equations we can write PP prime equal to 1.2 multiplied by 1.5 divided by 3, it will be 0.6. I made mistakes here. Actually it looks like comma, but actually it will be 1 point. It will be point. Maybe my typing mistakes. It will be point. So it is 0.6. This one, PP prime. So why not we write it? 0.6. Got it. Now let's move for this one, TT prime. Same way we have to do. Considering these two triangles, SRR prime and STT prime, both are similar triangles, so then TT prime, same procedure we have to follow. 1.2 multiplied by 1.5, it is not comma, 1.5 by 2 equal to 0.9. So why not write here 0.9? So we got. Now let's move ahead to see, once we apply on these cantilever parts uniformly distributed load, I mean uniformly distributed load, so what will be the value for this maximum negative moments? So let's see that. Now let's apply the uniformly distributed loads. So it is applied. 50 kilonewton per meter, 50 kilonewton per meters. It is applied on both ends on cantilever part. So we can write this point also. The maximum negative moment. For the maximum negative moment or maximum hogging moments, the uniformly distributed load should lie from P to Q and from AS to T. But here we need to think, say part of this or part of this, if we bring on this QS, this span, if we bring part of the load here or part of the load here, right away this value, I mean negative moment, surely it will be reduced. We will not get maximum hogging or maximum negative moments. That's why from the beginning we are thinking that these two distributed load must be only on the cantilever. Now let's find how to find this moment. The value of stress function of uniformly distributed load is obtained by multiplying the area under the, influence line diagram, this area under this load, this influence line diagram for stress functions within the range of this uniformly distributed load. Also we know the intensity. So it says this intensity, and under this influence line diagram, what we have here, just we need to multiply the area, this area of this influence line diagram, and this load to be multiplied. So we can write the formula very easily. This W multiplied by area of this on this load multiplied by area of this. So what is that area? Let's write it and calculate by calculator. So 50 minus half, because this is negative already I put here, half 0.6, we know this vertical ordinate is 0.6 and 1.5 it is the distance. So we get the area and multiplied by this W. So this is the value, and second part also this is the value. Using calculator we get 56.25 kilonewton meter. That is the maximum hogging moment at these points. That's why I put direction up. So I think we are done, and our out of 4 answers, I think A was this answer, A. So we have to put tick on A for this value. So that's all for these problems.